Welcome to the third video for week 9 for CIS 224 Data and Information course. So we've been talking about normalization, sort of a background on it in the last video. Before we get into talking about the actual normalization forms, there's two more concepts that I want to talk about. One we've already covered, and I just want to cover it in a little bit of different fashion, a little bit more in depth, and then there's another one. The second concept that is specific to normalization. So, primary key is something that we've talked about in the past. We've talked about foreign keys, we've talked about primary keys, but I just want to go a little bit more into depth with normalization. So we've talked about what a primary key is, how it cannot be null. It has to be unique, so there can only be one. So student ID or customer ID, only one customer has that. It needs to be, the only way to create a student is to create, if you were going to make the student ID a primary key, the only way to create a student would be to assign them a student ID. So we need to make sure that we're not confusing, because we've talked about entities and what makes up an entity. So the identifiers for an entity. So what is it that makes up a student? Everything that makes up a student is not a primary key. So we could say that you have to have a student's name in order to create a student record, but the student's name is not going to be a primary key. There are going to be multiple Sues, multiple Johns, multiple Toms, etc. There will be people that have the last name Schwartz, several of them. So it can't be a primary key because that won't be unique. We'll talk about this later, but the way we would take care of that is we would say name cannot be null. So that would allow, it would force the user to put in the name before they complete the record. But technically, for the database side, as long as they have a student ID, that would be the primary key. So primary keys do not change. It is very difficult to change a primary key once it's created. It's very difficult to change the format of a primary key. So we've had this conversation about whether a university, how they want to make their primary key. Is it all numeric, or do they want to start certain students with a letter? So Immaculata, I believe, starts theirs with a letter for continuing ed, I believe it's C, graduate school, and then the traditional school. So they've decided to have it to start with a letter. Some universities may not want to have the letter and they just want it all numeric. If you were a company that was creating a database for different universities, you would make it a text field so that universities could enter all numeric, because you can enter numbers in a text field, or they could enter letters if they wanted to do that. But once the decision's made, that's the way it is, and it can't be changed. It's very, very difficult to change it. And usually you basically just have to start all over. So how do we determine what the primary keys are? It can be based around business rules for certain tables. It can be based around something that we create. So in most of our databases, we have created a customer ID or an order ID. Those are created by the system as they go through. So there's it follows numeric. So it's something that the user may never see. In most cases, they probably will, but they may not be able to see it. And what that creates is a functional dependency. And we'll talk about functional dependencies next. It's the second concept I want to introduce. But basically, it's where an attribute of an entity determines other attributes, one or more attributes. So let's hold off on that. I'm going too much in for this slide. Primary keys can already exist. So, example of Comcast, we have for all of our modems, they have serial numbers. And we use those serial numbers as primary keys. So they're already generated for us. And then we can use, that'll how we create a primary key to uniquely identify a modem. Those are called surrogate or synthetic keys. I'm sorry. Those are natural keys. The keys that you would have to generate, a surrogate or a synthetic key, is one that you would have to create. So a customer ID would be a surrogate key. It's not required by the business. The business doesn't need that. The database needs it in order to function. If you were to have a small university or a small business, you could write out invoices. Back in the olden days, you would actually write out what the customer purchased, how much it cost, and you'd see those little invoice sheets that were handwritten with the date, and then you would write paid, you know, if they gave you cash, a credit, whatever, check. The business could operate without a customer ID. The database cannot operate without the customer ID. So there's a difference there. But you can look to create a key. So if you look at it, if we were to look at a student database, and let's just take out the student ID, and we looked at name, we looked at address, we looked at all the other things that make up a student. None of those things would be unique only for that student. So names wouldn't be unique. You could have two students that come from the same household, so their addresses are going to be the same. Their telephone numbers may be the same. Emails, you may be able to get away with that, but a lot of times what if they don't have an email? You couldn't create a student record if they didn't have an email. So all of those things, while they make up the entity of a student and make that student unique, none of them could function as a primary key. A lot of times you can combine different ones. So I think that's on the next slide. Yeah, so usually it is a single because it's easier. It's easier just to say a student ID or order ID or customer ID, and just make that up and make that number unique and have the database create that number behind the scenes for you rather than combine different ones. But it is possible to bring two keys together. So if we were to think back on the enrollment table that we created, the enrollment table has the student ID and it has the course ID. We could combine those two together to give us a primary key for the enrollment table if we so chose. So that's a way that you could bring the two together. You need to sit and think about it and what makes sense to for a table, whether you need to create one or not. Oftentimes, again, if we look back at the modems for Comcast, they have a built-in serial number. People don't come with built-in serial numbers, unless we're talking Minority Report. So we need to assign one to them. You could use driver's license. Maybe that's something. But that would mean if a student doesn't have a driver's license, they couldn't be a student. And again, so you can see why it's just easy just to give them a student ID. Because then they don't need to bring anything. We're not relying on any other systems in order to generate that. We can generate it for ourselves. We can use the primary keys from one table and foreign keys in another. So again, looking back to the enrollment table, the student ID would be the primary key for the student table. The course number would be the primary key for the course table. Together, they can either both be foreign keys in the enrollment table, or we could combine them for one primary key. Tables do not have to have primary keys. Usually something like the enrollment table, which is a junction table, you may not need that because you're going to pull the two. You're going to join it. The reason you would use the enrollment table is to figure out what students are taking what courses, or what courses have what students in them. So you're really just using the enrollment as a junction table. So you may not assign a primary key. It's not a requirement to assign for normalization or for data model to assign a primary key or foreign key. It just helps with searching later on and identifying unique ones. So that's a little bit more in depth with primary keys and how we go about judging them. The next thing I want to get into is functional dependency. I'm going to stop here and we will continue that in the next video.